I'm going to go through a second example here to solve a system of linear equations using the substitution method. So if you look, here's our first linear equation, which I'll call equation 1. And here's our second linear equation, which I'll call equation 2. In terms of this system, if you look at the coefficient of the x's, neither one is really a favorable one to rearrange. And if you look at the y's, it is the same. So in this case, neither coefficient of either the x's or the y's in either equation has a coefficient of 1 or -1. So in this situation, you really have to choose. And what I would do is I would look at this value here, whatever the equation is equal to, and I'd see what's best to divide this number by, 18. So when I look at these equations, I would say it's probably easier to divide 18 by 3 or 6 than it's going to be to divide by 5 or 4. Just because when we divide 18 by 3, or if we divide it by 6, it's going to give us a whole number. So I'm going to look at rearranging equation 1, and I'm going to rearrange it for y. Again, the reason I'm rearranging for equation y is because I'm looking at the coefficient of y and saying, look, it looks like this is more favorable to divide by than a 5. So when I rearrange this, look, I'm going to start by subtracting 5x from both sides of the equation. And this will leave me with negative 3y is equal to negative 5x plus 18. The last thing I'm going to do is divide everything by negative 3. And this will isolate y. So what I have is, for my rearranged equation, is x or y equals 5/3 x. And I'm not going to write that as I'm not going to write this as a decimal number. I'm going to leave it as a fraction. So if you divided this, you would get a repeating decimal. And often people round these repeating decimals, which isn't going to give us the exact same answer in the end. So I'd recommend leaving that alone. And then 18 divided negative 3 is going to be negative 6. So my rearranged equation looks like this. Now when I go to substitute this into equation 2, what's going to happen is this fraction, as bad as it looks right now, it will go away very quickly. So if I look at this, I'm going to replace this with my y. 4x minus 6y. Now y I'm saying is this, 5/3 x minus 6. And this is equal to 18. Again, the reason we're substituting this into the second equation is because we only want one single variable to solve. Okay, so if we have just x's in this equation, we can solve for x. So what we need to do is use the distributive property. So we have a negative 6 multiplied by 5/3. So this is negative 6 times 5, which is negative 30, divided by 3, which is negative 10x. And look, the fraction is gone. And then we have negative 6 multiplied by negative 6, which is a positive 36. And this is equal to 18. So if we combine our x values, this is negative 6x plus 36 equals 18. Now lastly, what we're going to do is rearrange this equation, isolate for x. So we have to use reverse bedmass, so we will subtract 36 first, which leaves us with negative 6 on the left side, and on the right side, this now is negative 18. And then we divide both sides by negative 6. X is equal to 3. So this is the x coordinate in our intersection point. Now to find the y, we would go back to this rearranged equation for y, and we'll substitute this in for x. So I'm replacing x in this equation with 3. 5 times 3 is 15. Divided by 3 is 5. So 5 minus 6, y is equal to negative 1. So the solution is this, negative 1 and 3. Again, we can verify this solution by checking it in both equations. So to verify this, I'm going to look at equation 1 first. So it's 5x minus 3y equals 18. So if I replace my x with negative 1 and my y with 3, I get 5 times negative 1 is negative 5. and whoops, I mixed these up. Sorry, x was 3, and I wrote it wrong here in this coordinate as well. X is actually 3, and y is -1. So this should be 3, and this should be -1. So 5 times 3 is 15, and -3 times -1 is +3. 15 plus 3 is 18. 18 equals 18. So the left side equals the right side in this equation, so this solution works. For solution 2, or for equation 2, we need to verify this as well to see if this solution works in here. So what we do, again, we replace our x with 3 and our y with -1. And 4 times 3 is 12, and -6 times -1 is 6. 12 plus 6 is 18. Again, if we look at this, the left side is equal to the right side. So this solution of 3 and -1 works in both equations, so this is our solution.